is Manikant Reddy from ARE College. I'm studying BTech first year. My branch is Cybersecurity Section A. Today I want to explain about capacitors and connection, how we connect the capacitors in series, like series of parallel. So today we will look at into capacitors and total detail I will explain more clearly. So first of all, I want to share with PPT, so it will more convenient to my explanation. Just a minute. Okay, here is my PPT. Your subject is basic electrical engineering and topic is series and parallel connections of capacitors. So your, myself, Manikant Reddy, roll number is 72951 A6238. Okay, from section A. Here is the objectives, like after completing this module, after completing this class, so you should be able to calculate the equivalent capacitance of a number of capacitors connected in a series or in a parallel. Mainly focus on series and parallel. Determine the charge and voltage across the chosen capacitors and equal when given capacitors and externally applied potential difference. Okay. After completing this class, you are suppose you know you are going to know about equivalent, what is equivalent capacitance, what is actually mean by capacitance, what is series connection, what is parallel connection of capacitor, and how to find the equivalent capacitors of series connections and parallel connections. You all are going to know about this, and how to find the charge in a capacitors and voltage across 2 points, two ends of the capacitors. These are all you all I will explain in this class today. Okay, you are all going to know about this. We will go into next slide. First, electrical symbols. Electrical circuits often contain two or more capacitors grouped together and attached to an energy source, such as battery. Electrical circuits often contain two or more capacitors grouped together, two or more capacitors, 2, 3, 4, like that, more capacitors together and attached or connected to an energy source, so that's battery. The following symbols are often used. First one, ground means they are connected to earth, and battery symbol is there. One is positive, one big line is a positive, and one broad line is there, and that one is negative. And capacitors, two equal lines, two parallel equal lines, and attached to horizontal two lines. These are the symbols. These three symbols you must remember all these symbols. Then only you can understand equivalent resistance and the series connection, the parallel connection. These must you have to know about this. Okay, and further, series circuits, capacitors, or other devices connected along single path are said to be connected in series. See a circuit below. Here I will explain capacitors. Two or more capacitors are connected in a single path. Connected in a single path are said to be in series. Okay. Here in the circuit, first capacitor, I will annotate this. This is the one. This is the second. This is the third. Okay. Three capacitors are given in the circuit, and first capacitor. This is a plate. This is the plate. Charges are here, present here. Okay. First capacitor positive connected to battery positive. Here is a big plate. What I said, big plate is a positive, and small plate. No, small plate is denoted by negative symbol. Okay. Battery positive terminal of a battery is connected to positive terminal of a first capacitor, and negative terminal of a capacitor, first capacitor, negative terminal of a first capacitor is connected to second capacitor, positive terminal. Okay. Here you can observe that positive to positive first capacitor, and here reverse, and negative terminal of a first capacitor is connected to second capacitor, positive terminal. Okay, and only single path is there here. This way. In this way, charges are flowing, and here returns to battery. Okay. The second capacitor, the positive terminal of a second capacitor is connected to first negative terminal of a first capacitor, and negative terminal of a second capacitor is connected to third capacitor of positive terminal, and third capacitor negative terminal is connected to negative terminal of a battery. Here is the path of a series connection. Okay. Charge inside dots is included. Charges is there here. These are included. Okay. I will write all this. I hope you are understanding all this. Okay. Okay, I explain all this. I explain. Okay, charges on capacitors in series. How charges will denote and okay, since inside the charge is only induced, the charge on each capacitor is same. So in the series connection, charge is same. Charge is same in series connection of capacitors only, not resistors, not inductors. Only in capacitors, charges are same in capacitors. Okay, first overall charge is Q. Suppose I will tell you here charge producing is Q. Here Q1, either Q2, either Q3. Q equal to Q1 equal to Q2 equal to Q3 here. Understood? I hope you are understanding. Here the main important point is that charge is same. charge is saved in series connection of a capacitors. Okay, I hope you're understanding this. Okay, chalo. Voltage on a capacitors in a series connection. Before slide, in the second slide, we saw that series connection in parallel, how series connection made by capacitors. And before slide, we saw that charges on each capacitor in series connection is same. Now voltage on capacitors in a series, how voltage is variant or the same on capacitors in series. We will see that since the potential difference between the points A and B, the potential difference between the point A and B here is the area of this. Potential difference between the one A and B is the battery voltage B. But somehow the voltage is not equal. Your other capacitor is but how charge could be say you equal to same. But voltage, the total voltage of the connection is not the voltage. Suppose here third only we have two voltages. The voltage of the battery in series connection of capacitor. Okay, I hope you are understanding this. I will also clear all this. Okay. One, just a minute. There is an equivalent capacitance series. Equivalent capacitance series. How we are going to calculate the equivalent capacitance in series connection? First, I already told you that in first slide only. Objective what you have learned after the class. First of all, you must going to know about the capacitance and the series connections and parallel connection and charges on the series connection and charges on the parallel connection and that voltage is also are going to learn how we are going to learn equivalent capacitance. Here we are calculating the equivalent capacitance. No, suppose C denotes the capacitance of the capacitor. How we are going to calculate the charge of the individual capacitor divided by voltage of the individual capacitor, right? Okay. By this formula, some of the individual voltages of capacitors is equal to voltage of the battery. We all know V equal to how many capacitors are there? 3 capacitors are there here. Okay. V equal to V1 plus V2 plus V3. We all know this formula. V equal to Q by V equal to Q by C. Here transporting V here and C here. Okay. Video lying by much. Yeah, now it's clear. V equal to Q by C. Substituting in this values. V Q by C. V1 equal to Q1 by C1. V2 equal to Q2 by C2. V3 equal to Q3 by C3. We all know about this. Charges on the each capacitor is same. So Q1 equal to Q2 equal to Q3 equal to Q. Okay. We'll take a common this Q and cancel all this. We all know this formula. 1 by C equal to 1 by C1 plus 1 by C2 plus 1 by C3. Equivalent capacitance for the capacitor in series equal to 1 by C. C equivalent equal to summation of I equal to 1 to n 1 by C. This is the important formula in this. Okay. So equivalent capacitors in a series. This is the most important. You must remember all this. Okay. We'll go into further. Sorry. Okay. Shortcut 2 series capacitors. 2 equivalent capacitors after 2 series capacitors. Product divided by sum. Suppose in circuit 2 capacitors are there. We have to find equivalent capacitance. So the formula is product of the capacitance of 2 capacitors by sum of the capacitance of two capacitors, right? Product of two capacitance of the capacitor, individual capacitor, divided by sum of individual capacitance of individual capacitors. Okay. No confusion in there. I will explain clearly with the example. Here is the example. Two capacitors are there. One with 3 microfarad. Here capacitance units are farad. Okay, capacitor, first capacitor capacitance is 3 microfarad, and second capacitor capacitance is 6 microfarad. So we have to find equivalent capacitance. So what is the formula? Product of individual capacitance of individual capacitors by divided by sum of individual capacitance of individual capacitors. So product of two individual capacitance. Okay, 3 into 6 by 3 plus 6. How much? Total equivalent capacitance is 2 microfarad. Okay, 3 6 are 18. 18 divided by 9. Okay, microfarad. 9 to 18, 2 microfarad. Total equivalent capacitance is 2 microfarad. Okay, now we will see parallel circuits, capacitors which are all connected to the same source of a potential are said to be connected in parallel. Civil. Now we'll see. We have already learned about series connection of capacitors. Now onwards, I will explain parallel circuits in capacitors. Capacitors which are connected to the same source of potential are said to be connected in a parallel civil. Okay. Now, parallel capacitors, positive to positive, negative to negative. This line, you must remember it is a shortcut. Okay. This big plate is indicating what? Positive terminal, and this small plate, this broad plate is indicating negative plate. Okay. Here is the capacitors are connected. Here, first capacitor and second capacitor and third capacitor. Here, positive, negative. Second capacitor, positive, negative. Third, first capacitor, positive, negative. Okay, clear. This positive is connected toward capacitance of the first positive, first capacitor positive terminal, and the positive is connected to which terminal? Second capacitor positive terminal, and third capacitor positive terminal also connected to battery positive terminal, and negative terminal is connected to which terminal? This all connected to first terminal negative terminal, second capacitance negative terminal, and third capacitance negative terminal. Okay, the charges are flowing in this way. The charges are going in this way. Okay, here voltages are same in parallel connection. We all know. In series connection, charges are same, voltages are different. Here in parallel connection, voltages are same, charges are different. Here V, here also V, here also V, here also V. Same voltage in every circuit. If any metal or resistance or inductor or capacitor, those are connected in a parallel, you must remember that voltages are same, charges are different. Charge on the battery is equal to sum of the individual charges on each capacitor. Okay, here is the formula here. Charges Q total. Q total denotes what? Q total denotes battery charge of the battery, and Q1 denotes the charge of the first capacitor. Q2 denotes charge of the second capacitor, and Q3 denotes charge on the third capacitor. Here we'll see the formula of what? Equivalent capacitance. Okay. Equivalent capacitance parallel. Here is the circuit. You all before slide you also saw that C equal to Q by V. We all know that Q equal to CV, right? C equal to Q by V is the formula. Capacitance is equal to charge on capacitance by voltage on capacitance. Okay. Here Q, what is the charge on a capacitance? Product of capacitance and voltage. Here we all know that in parallel connection, charge on the battery is equal to sum of the charges on each capacitor. Okay. Q equal to Q1 plus Q2 plus Q3. Here we have 3 capacitors for them. Here also three charges are we have written. Okay. Equal voltages. Q equal to CV. Q1 equal to C1 V1. Q2 equal to C2 V2. Q3 equal to C3 V3. Okay. What is the voltage on battery V? What is the capacitance? C1 V1. C2 V2. C3 V3. Okay. We all know that equal voltages are there. Okay. CV1, CV, C1 V1, C2 V2, C3 V3. We all know so voltages are equal. So we must be cancelled. C equal to C1 plus C2 plus C equivalent equal to C1 plus C2 plus C3. Equivalent capacitors of in a parallel equal to summation of each capacitance. Okay. Okay. Here I want to end. Thank you so much. Okay. Thank you.